Welcome everyone. This is the third video in the series of linear differential equation, and in this video I will talk about operator method of solving non-homogeneous linear differential equation. How does this work? To write the solution, we write y is equal to complementary function plus particular integral. What is complementary function? That we already know. Complementary function is the same thing which is the solution of its corresponding homogeneous linear differential equation. I hope you might not have understood, but I will explain through examples. So to make sense of it, let us start with the examples. So suppose we have to solve this equation. So first of all, I want you to recognize that this is a non-homogeneous linear differential equation because the right hand side is exponential function. It is not equal to 0. Whenever we apply the operator method, it is preferred to first write the differential equation in terms of d. When I say d, what I mean is we already have seen it in the previous video, that here I will be writing capital D, which will stand for the differential operator d by dx. So this differential equation can be rewritten, and it can be rewritten as d square y because it is y double dash. So I hope you remember that d stands for d by dx, d square stands for d2 by dx square, d cube stands for d cube by dx cube, and so on. So y double dash can be written as d square y, minus 2y dash can be written as 2 dy, and minus 3y is equal to 3 e to the power 2x. So which in turn can be written as what? Which in turn can be written as, let me write it again for better clarity. So I can write it d square minus 2d minus 3y is equal to 3 e to the power 2x. So basically there is no difference between these two things, but it is always better to write the differential equation in this form, especially when we are solving this through the operator method. So what is the solution? As I told you that solution will be, I will write that the solution is given by y is equal to complementary function part plus particular integral part. What is complementary function? So to first get the complementary function, we are going to solve the corresponding homogeneous linear differential equation. So if I ask you what is corresponding homogeneous linear differential equation of this equation, then you should say that it is d square minus 2d minus 3y is equal to 0. The right hand side I will assume is equal to 0. So if I ask you how to solve it, then do you remember the process? You first write the auxiliary equation. So what is the auxiliary equation in this case? The auxiliary equation is m square minus 2m minus 3 is equal to 0, right? So we can factorize it, and if we factorize, we will get m square minus 3m plus m minus 3 is equal to 0, right? So here I can take m common, m minus 3, and plus 1 common, m minus 3 is equal to 0. So what we get? We get m minus 3 into m plus 1 is equal to 0. So we got two roots, that is m is equal to 3 and minus 1. So what is the complementary function? The complementary function is c1 e to the power 3x plus c2 e to the power minus x. So it is the same thing which is the solution here in case of the homogeneous linear differential equation, right? But from the next problem onwards, I will not be writing the detail about the complementary function, but since I wanted to give you the clarity about the process, I have written it in the detail. Now our aim here in this video is to understand how to find the pi. So to find pi, what we do, first of all, if you look at this problem, just to understand it, it can also be seen as what? It can be seen as this thing I am considering fd, a function of d. What is fd here? Fd here is d square minus 2d minus 3. So this differential equation can be seen as what? This differential equation can be seen as fd, if it is operated on y, gives us 3 e to the power 2x. So since we want to solve it for y, what we can do? I will operate 1 by fd. 1 by fd on the right hand side, that is e to the power 3 into e to the power 2x. So this 1 by fd is known as the inverse operator of fd. It should not be confused with 1 divided by fd. If fd is this operator, then what is the inverse operator of this operator? That I will represent by 1 by fd. So the process of finding the particular integral is that what we do, we write the pi as 1 by fd. So 1 by fd here is d square minus 2d minus 3, and that we operate on the right hand side, that is 3 e to the power 2x. And how to apply this operator here? For that we already have a standard result. So what is this result? This result is telling you that if you operate 1 by fd on e to the power ax, you just have to replace the term d by the coefficient a here. So the function 1 by fd becomes 1 by fa. Only thing that we need to take care is that fa should not be equal to 0. If the denominator, if this fa becomes 0, then this result will not work. That will be considered a case of failure. How to solve the problem in that situation, that I will be discussing in the next part, means in this video only, but later. So let's proceed now. So 3 is a constant, so I can take 3 out of this operator. This operator behaves like a differential operator, so the 3 can be taken out. And then we have what is the value of a here? It is e to the power 2x, so the value of a is 2. So in place of d, because we have to replace what? We have to replace d by a. So we have to write, in place of d we have to write 2. So I will write 2 square minus 2 into 2 minus 3 e to the power 2x. So this 2 square is 4 and 2 into 2 is 4 also. So this 4 minus 4 is cancelled, and here we have 3 and here we have minus 3. So what I get is minus e to the power 2x. So what I have got is known as the particular integral. Right now, how should I write the solution? So the solution should be written as y is equal to complementary function. So what is complementary function? c1 e to the power 3x plus c2 e to the power minus x and plus the particular integral. So particular integral in this case is minus e to the power 2x. So this is how we solve this problem. Okay. To make more sense of it, I am going to take more problems. So only thing that we need to remember, let me summarize this, that to write the complementary function, we solve the differential equation by considering that the right hand side is equal to 0, means we take the solution which corresponds to the corresponding homogeneous equation part, and then we find the pi. And to find the pi, in case if there is an exponential function, we apply this formula. You might be thinking, what if there is some other kind of function? So we are going to look at each of them one by one. So there are certain standard results, I'll be discussing them one by one. So let us solve this problem for having better clarity. So here also, if I have to write the solution should be written as y is equal to complementary function plus particular integral. And before I solve it, I hope you can clearly see that this differential equation can be seen as y triple dash, so d cube minus 2y double dash or y double prime, so that is 2d square minus 5d plus 6 y is equal to 4 e to the power minus x minus e to the power 2x. I have not talked in detail about this because I already have talked about this in the previous video. Now to find the CF, first we write the auxiliary equation. So what is the auxiliary equation? The auxiliary equation is we can write m cube minus 2m square minus 5m and plus 6 is equal to 0. And in this case I am not going to solve in detail. When you will be solving, you have to find the roots, but since we want to focus more on particular integral part, because how to solve this, how to write this solution, that we have discussed in a very detail in the previous videos. I am writing the roots directly and you need to verify that whether it is correct or not. So 1 minus 2 and 3, this is a cubic equation, so it will have 3 roots. So what will be the complementary function? The complementary function will be c1 e to the power x plus c2 e to the power minus 2x plus c3 e to the power 3x. What is the particular integral? Now I have to operate the inverse operator of this. So what is the inverse operator of this? 1 by d cube minus 2d square minus 5d plus 6, and that we need to operate on the right hand side, that is 4e to the power minus x minus e to the power 2x. Now there are two terms here in the right hand side, so this operator will be operated separately on both these terms. So if I operate separately on both this term, the coefficient of first term is 4, which is a constant, so I can take it out. And here what is the x value, a value? So a value means it is minus x, so a value here is minus 1. The coefficient of x is minus 1. And what is the process? We have to replace d by a. So in place of d I will be putting minus 1, so I will be getting what? I will be getting minus 1 cube minus 2 into minus 1 square minus 5 into minus 1 plus 6, and that we are operating on e to the power minus x. Okay, and minus I need to operate this on the second term also, but in second, what is a? A is 2, so now I need to replace this d by 2, so I will get 1 by, and in place of d I will write 2 cube minus 2 into 2 square minus 5 into 2 plus 6 e to the power 2x. The application of this formula that I have written, and this is the very important first formula that you need to keep in mind. So now I just need to simplify, which is a very easy thing for you. So 4 1, and this is minus 1, this is minus 2, this is plus 5, and this is plus 6. Yes or no? And we have e to the power minus x, and minus how much is this? This is basically 8. 2 cube is 8, and 2 minus 2 square, that is also 8. So 8 and minus 8, this term will be cancelled, and here I will get 5 into 2, that is minus 10 plus 6, so minus 4. So I will get 1 by minus 4 e to the power 2x. So if I simplify, it is 4, and 6 plus 5 11, and minus 3, so 11 minus 3 is 8. 4 by 8, that is equal to 1 by 2 e to the power minus x, and this minus minus plus, so I get 1 by 4 e to the power 2x. So this is pi part. So how do I write the general solution? The general solution is y is equal to complementary function, that is c1 e to the power x plus c2 e to the power minus 2x plus c3 e to the power 3x, and plus the particular integral, that is half e to the power minus x plus 1 by 4 e to the power 2x. So I believe with these two problems you are clear about the process, that how to solve the homogeneous non-homogeneous linear differential equation when the right hand side is equal to an exponential function, right? So the process is simple, just operate 1 by fd, and what is 1 by fd I hope is clear to you. Write the differential equation in the form of what? In the form of fd over y, and then whatever is the right hand side. So this is the nature of the differential equation. To solve to find the CF, what we do, we take fd is equal to 0, means corresponding homogeneous linear differential equation, fdy is equal to 0, and solve it, but we don't call it y. In this case we call it complementary function, and then we find the particular integral. So let us look at this problem now. This problem is a situation in which the FA becomes 0, because when I was talking about this result, I told you that you can apply this formula only in the case when FA is not equal to 0. So what if FA is equal to 0? So here also we have to write the solution y as complementary function plus particular integral, right? And before I write this everything, let me write the differential equation in operator form. So I can write it d square plus d minus 6 y is equal to 5 e to the power minus 3x. And I again repeat, I hope it is clear to you that how to write it. In case if you are not clear, then please do watch my previous video, the video number 2 in this series. You will be able to understand. Now to find the CF, I have to write the auxiliary equation. So the auxiliary equation is m square plus m minus 6 is equal to 0. And again I am saying that I am not going to find the roots and everything in the detail. So here if you solve it, you will get the root as m is equal to minus 3 and 2. So the CF part, the complementary function part, is c1 e to the power minus 3x plus c2 e to the power 2x. Now how do you find pi? So to find pi, you write 1 by fd. So what is fd here? D square plus d minus 6, and that we need to operate on 5 e to the power minus 3x. So 5 is a constant which I take out of the operator, and I write 1 by d square plus d minus 6 and operate it on e to the power minus 3x. But what I want you to note, that in place, what is a here? A here is minus 3. So if you replace d by minus 3, what will happen? Minus 3 square, so minus 3 square, minus 3 and minus 6. So this will be 9 minus 9 is equal to 0. But as I told you that we can replace d by a only when this fa things does not become 0. So what we need to do in this kind of situation, and that I am going to explain very carefully because this is an important situation. So the process is that what we do, we have the term 5 here, so we just copy it. We multiply x before the operator, means we take x before the operator, right? Means this x is taken before the operator is, this x is independent of the operator, right? So you just multiply x in the beginning, and then you differentiate this function fd with respect to d. With respect to what? With respect to capital D. So what I am suggesting is that we have to actually differentiate d by dd of d square plus d minus 6. So if you differentiate this, what you will get? You will get 2d plus 1. So if I differentiate this with respect to d, I will write here 2d plus 1 e to the power minus 3x. Now I will check whether we can replace d by a or not. So here if I replace d, that is a, that is minus 3, and if I put minus 3 in place of d, it will not be 0. So now we can apply the original formula. So it is 5x 1 by 2 into minus 3, that is minus 6 plus 1 e to the power minus 3x. So it will be minus 5 and it will be 5, so it will be cancelled, and I will get minus x e to the power minus 3x. So what is the general solution? The general solution is c1 e to the power minus 3x plus c2 e to the power 2x and minus x e to the power minus 3x. Okay. I hope you also have noted this thing, that this is a differential equation of order 2, so its general solution is containing 2 arbitrary constant, right? I am going to take 1 or 2 more question related to the case of failure, so be careful. So here in this case, again I will write y is equal to cf plus pi, and like every time I am doing, before I am solving this, I am writing it in operator form. So I am writing 4d square minus 4d plus 1 y is equal to e to the power x by 2, right? So what is the auxiliary equation? The auxiliary equation is here 4m square minus 4m plus 1 is equal to 0. And ladies and gentlemen, I hope you are smart enough to see that this is nothing but 2m minus 1 whole square is equal to 0. So basically m is equal to half and half, right? So what is the complementary function? Complementary function is c1 plus c2x. I hope you know the way of writing the complementary function. Means it is a case of repeated root. If you didn't get this point, you need to watch the previous video, because this is expected that you have watched the previous video. In case if you are new to the channel and have not watched, and you do have the understanding of solving homogeneous equation, then I feel that you might be getting. Now I need to write the pi, so I need to write the pi. So here to write the pi, we take the inverse operator of this. So what is the inverse operator of this? 1 by 4d square minus 4d plus 1 e to the power x by 2. And you can clearly see that I have got the root 1 by 2. So in place of this, if I put d is equal to 1 by 2, it will become 0. Yes or no? Did you get it or not? Now what is the process that if I just replace d here by 1 by 2, because a is 1 by 2, this expression will become 0, so that I can't do. So what is the process? Multiply by x in the beginning and then differentiate this thing, the denominator, with respect to d. So 4d square will give me 8d, and minus 4 if I differentiate this with respect to d, and e to the power x by 2. Now note one more time that in this case also, if you put d is equal to 1 by 2, you will get 8 into 1 by 2, that is 4 minus 4, so you will again 0. So you can't again replace d by 1 by 2. So you have to repeat the same process. You have to multiply by x again in the beginning. So x is already there. We multiplied by another x, and then we repeated the same thing. We are going to differentiate this. So I'll be getting 8 e to the power x by 2. Now we already have got rid of the differential term. So what we got is x square by 8 e to the power x by 2. So what is the general solution? Y is equal to c1 plus c2x e to the power half x plus x square by 8 e to the power x by 2. Right. Just to make more sense of it, I am going to quickly take one problem which will give you more clarity about this process, and I am going to write here 1 by d cube. This is an independent problem. I already have given you the solution of this, but just to make the things more clear, suppose I write a problem of directly finding the pi. So suppose I am calculating a pi, and the pi is like this, that d cube minus 3d squared plus 3d and minus 1, and suppose it is being operated on e to the power x. So in the first case, if you put d is equal to 1, you can clearly see that 1 minus 3 plus 3 minus 1, so it will become 0. So I can't directly put d is equal to 1. So what we do, we multiply it by x and then we differentiate it with respect to d. So d cube will give me 3d square, it will give me minus 6d, and it will give me plus 3, and that I need to operate on e to the power x. Now let's do the replacement, d by 1, so it will become 3 minus 6 plus 3. So 3 plus 3 minus 6 is again 0. So what we need to do, we need to repeat the process. So I again multiply it by x, so it becomes x square. We differentiate it, so we get 6d minus 6 e to the power x. Now check it again. If you put d is equal to 1, it again becomes 0. 1 by 6 minus 6, so that is 0. So repeat it one more time, so it will become multiplied by x, so x square will become x cube, and if you differentiate it with respect to d, you will get 1 by 6 e to the power x. So the answer is 1 by 6 x cube e to the power x. So I hope you have understood the process. We repeat the multiplication by x in the beginning and differentiation of the denominator term till the time we get a non-zero denominator, right? So I hope the process is clear up to now. So before I move to the next type, I am going to take this problem, and in this again I am not going to find the CF part. CF part we already have done in detail. So if you just write this differential equation in the operator form, it will look like 9d cube plus 3d square minus 5d plus 1 y is equal to 42 e to the power x and plus 64 e to the power x by 3. Right. So how to solve it? I hope you have understood the process, that y is equal to CF plus PI. CF is your homework kind of thing. You find the CF. I am going to directly find the PI. So the PI will be 1 by, and I need to take the inverse operator, so 9d cube plus 3d square minus 5d plus 1 and 42 e to the power x plus 64 e to the power x by 3. So if you operate this operator on this, first of all check whether I can replace d by 1 or not. So if I put d is equal to 1, I will get 9 plus 3 12 plus 1 13 minus 5, that is 8. So here there is no problem. We can replace d by 1 if I operate it on this. So I'm writing 42 and 1 by, in place of d I am putting 1, so 9 into 1 cube plus 3 into 1 square minus 5 into 1 plus 1 e to the power x. So I'm done with this part. But the problem here is that if you replace this d by 1 by 3, what is the coefficient of x here? It is 1 by 3. So you can just verify that if you replace d by 1 by 3, what you will get? You will get 9, d cube will become 1 by 27 plus 3, d square will become 1 by 9 minus 5 into 1 by 3, that is 5 by 3 plus 1. So what you will get? 9 by 27, that is 1 by 3, 3 by 9, so that is also 1 by 3, and minus 5 by 3 plus 1. So 1 by 3, 1 by 3, 2 by 3 plus 1 by 3, 5 by 3 minus 5 by 3 is equal to 0. So it means that in this case we can't directly do the substitution. So what we have to do, 64 is a constant, so I will take it outside, and then in the beginning we multiply it by x and we differentiate the denominator with respect to d. So if I differentiate this with respect to d, I will get 27 d square plus 6d minus 5 e to the power x by 3, right? Now can we so let me first write this part. So this part becomes what? 42, 9 plus 3 12 plus 1 13 minus 5. So 13 minus 5 is how much? 13 minus 5 I guess is 8, and e to the power x. Done with the first part. Second is 64x. And if I again check that can we replace this d by 1 by 3. So if I do that, you can see 27 d square will become 1 by 9 plus 6 into 1 by 3 and minus 5. So what I get? 6 by 3 is 2 and 27 by 9 is equal to 3. So 3 plus 2 5 minus 5 again 0. So we can't do the replacement here. So what we have to do, we again have to multiply it by x in the beginning and we have to differentiate it. So I will get 54d plus 6 e to the power x by 3. So 42 by 8 can be written as 21 by 4 e to the power x plus 64x square, and here I think I can substitute 1 by 3 now. So if I substitute 54 into 1 by 3 plus 6, so it will be 18 plus 6 is 24, so I will get 1 by 24 e to the power x by 3. You can simplify it. After simplification you can write 21 e to the power x plus it will be 8, it will be 3 by 8, it will be 8, so it will be like 8 by 3 x square e to the power x by 3. So this is the PI part. CF part is something that you have to do it yourself. Okay, so I think if these two types of problems are asked, you won't find it difficult to solve it. Now the next type, and this is also very important type, type 2. So in this type we are using the formula that here we are operating 1 by fd square, not 1 by fd, and if I operate 1 by fd square on sine ax, the d square is replaced by minus a square. And dear students, don't make a mistake, because I have noted a student replacing it by minus a square. This is wrong. It is not minus a whole square, but rather it is a square with a minus sign, right? And this result is also applicable when this f minus a square is not equal to 0. We have the same result for cos function also, right? So to solve it, let me take this example, right? I think we have the same example on the next page, so let me take this example here. So here what will be the solution? The solution should also be written as CA plus PI, right? It is a common trend, and before I solve this, make sure that you write it in operator form. d square plus 4y is equal to 6 cos x, right? So what is the complementary what is the auxiliary equation? The auxiliary equation is m square plus 4 is equal to 0. So this will give me imaginary pair of root m is equal to plus minus 2 iota. So the complementary function part is equal to c1 cos 2x plus c2 sine 2x. Our aim is to find the pi, and from the next problem I won't be finding any CF. So what is pi? What is the inverse operator of d square plus 4? That is 1 by d square plus 4, and that we need to operate on cos x. So for your convenience I am rewriting the formula here. The formula that we have to apply is 1 by f d square of cos ax, and this is equal to 1 by f of minus a square of cos ax. So first of all, 6 is a constant, so 6 is taken out of the operator. And what is a here? A here is 1. Coefficient of x is 1. What is a square? A square is 1. What is minus a square? So minus a square is minus 1. So in place of d square, I repeat, in place of d square, not there is no d, it is d square. So I am writing minus 1 plus 4 and cos x. So what did I get? I got 6 by 3, that is 2 cos x. So what is the general solution? Y is equal to the complementary function, that is c1 cos 2x plus c2 sine 2x and plus 2 cos x. So this is how we can write the general solution in case the right hand side is equal to cos function. Okay, let us solve this problem. Here this is cos also, you could have taken sine. Sine and cos, the function works similar way, so no confusion. I'm not going to find the CF part. So here the operator form is 2d square plus d minus 1 y is equal to 16 cos 2x. The general solution will be written as y is equal to complementary function part plus particular integral part. How to find the CF? That is your homework. I'm going to find the pi. So pi is 1 by 2d square plus d minus 1, and that I need to operate on 16 cos 2x. 16 is a constant outside, and I write 1 by 2d square plus d minus 1 cos 2x. So ladies and gentlemen, this problem will help you to understand the concept better. The formula that we are going to use is suggesting that you need to replace d square by minus a square, not d. Here in this term we have a d square term, we have a d term, and we have a constant term. So the formula is suggesting me that replace d square by minus a square. So you may ask, what about d? We will not touch d. So how to get rid of d, that I will talk later. So I am just doing the same thing. So 16 1 by, and in place of d square I am going to write minus a square. So here a is 2, a square is 4, so minus a square is minus 4. So in place of d square I am going to put minus 4 and plus d minus 1 on cos 2x. This will be like 16 and 1 by, you can see it is minus 8, and here we have d, so I write d, and minus 8 and minus 1 is minus 9 cos 2x. The machine or the operator or the formula that we are using is replacing d square by minus a square, but if we have d here, so in this kind of situation what we do, we operate d plus 1 in the numerator, and then we operate its inverse operator. So d plus 9 and d minus 9, if I operate on d minus 9, sorry, I hope I am not mixing the things. What I am saying is that here I am operating d plus 9, and in the denominator also I need to operate d plus 9. So d plus 9, and here we have d minus 9. See, basically I am not using the term multiplication, so we are using an operator d plus 1 and its inverse operator, so they both will nullify or cancel the effect of each other. But for your understanding, you can consider like that to get d square in the denominator, I have multiplied it by d plus 9 and d minus 9, and this is a process. So if you get something like 3d plus 4 in the end, then you multiply it by 3d minus 4, so that you get d square and the constant term. So what I will get? I will get 16 and d plus 9, and here I will get d square minus 81, and that I am operating on cos 2x. So I am getting 16 d plus 9, and what I need to do now, we can replace d square by minus 4. So I will get minus 4 here and minus 81. So let me write it, minus 4 and minus 81. That I need to operate on cos 2x. So now we have 16 here, we have minus 85 here, so minus 16 by 85, and we have d plus 9 of cos 2x. Now students, it is important to understand that if I write somewhere d plus 9 of cos 2x, what is basically d? D basically stands for d by dx, right? So this d is nothing but d by dx. So if I have to take d by dx of cos 2x, I will get minus 2 sin 2x, right? I am writing derivative of cos 2x because d stands for derivative. If it is d square means second order derivative. If it is dq means third order derivative. But it is just the derivative. So if I differentiate d of cos 2x, I get minus 2 sin 2x, and 9 into cos 2x, so I will get just 9 cos 2x, right? So in the end, if I have to write it, what I will write? I will write minus 16 by 85, and derivative of cos 2x, so that is minus 2 sin 2x and plus 9 cos 2x. So this is my PI for this particular problem. How to find CF? I hope you know that. Okay. So let me take this problem to make more sense about finding the PI in case of the right hand side being sine or cosine. So as you already have seen, now I am not going to write CF, PI and everything. So the operator form of this will be d square minus 5d plus 4 and sine of y is equal to 65 sine 2x. Just PI part, I am not going to find all the terms. So what is PI in this case? And actually in the question also they have written find the PI. Sorry, I missed one thing. Here it was written general solution, but in this question basically they wanted me to find PI only. So here also I am actually finding the PI only. So what is PI? 1 by inverse operator of d square minus 5d plus 4. So d square minus 5d plus 4, and that we are operating on 65 sine 2x. So you need to read the question carefully, whether they are just asking you to find the PI or the general solution. But I hope you have understood the thing that if I have to find the general solution, I write y is equal to CF plus PI. In case of PI, this is what we have to do. So 65 is a constant and out of operator, and here a is 2. So d square will be replaced by what? D square will be replaced by minus a square. So a square is 4, minus a square is minus 4. So minus 4 minus 5d plus 4 sine 2x. And here we have a nice situation that minus 4 and plus 4 is cancelled. And we have minus 5 and 65, so I get minus 13. And here we have 1 by d of sine 2x. As I told you that d is the differential operator, that is d by dx, and 1 by d is the inverse of d. So if d is the differential operator, 1 by d is nothing but integral operator. It is just the integral, because differentiation and integration are inverse process of each other. Yes or no? So we have minus 13 and 1 by d is the integration of sine 2x. So I will get minus cos 2x by 2. So what is the PI in this case? The PI in this case is 13 by 2 cos 2x. Okay, fine. So now in this case also, as I told you that this result I am applying only when f of minus a square is not equal to 0. So what if f of minus a square is equal to 0? So this will be a case of failure, and the case of failure here also will be dealt with in the similar way. So let's do this problem to understand it. This video is going to be a slightly long video. My format of creating video is to create long videos so that every concept is there in the one video. In the first video that I have created, I have discussed the complete unit number 2, right? And every concept is mentioned over there. So here also in operator method I am going to take all kind of problems, so be with me till the very end to get better idea of this. So let's solve this problem of the case of failure. So first of all, if I have to solve this, what is the solution? As every time I am writing y is equal to CF plus PI, and every time for our convenience we are first writing it in the operator form. So d square plus 4 y is equal to cos 2x. Okay, so what will be the CF in this case? If I can quickly find the CF also, the auxiliary equation is m square plus 4 is equal to 0, so that will give me m is equal to plus minus 2i. So the complementary function will be c1 cos 2x plus c2 sin 2x. What is the particular integral? So particular integral will be 1 by d square plus 4, and that I am operating on cos 2x. So ladies and gentlemen, if you replace d square by minus a square, which in this case is basically minus 2a square, that is minus 4, so it will become 1 by minus 4 plus 4 is equal to 0. So whenever we have this situation, I already have given you the general idea. What is the idea? That multiply it in the beginning by x, before the operator put x, and then differentiate this. So if you differentiate this, you get 1 by 2d of cos 2x, right? So this will be like what? This will be x by 2, and 1 by d of cos 2x. We know that 1 by d is the integral. So integral of cos 2x is x by 2, and that is sin 2x by 2. So what is the general solution? General solution is y is equal to c1 cos 2x plus c2 sin 2x and plus x by 4 sin 2x. So in case of failure also we are dealing the problem in the similar way. If I have to solve this again, what is the solution? First of all, this differential equation can be written as d square plus 1y is equal to 0. So I'm just going to find the particular integral. Here also they wanted the particular integral. Actually in this problem also they have asked for particular integral. See, I actually missed an because in I am focused on problem solving, I am missing that what they are expecting. So I am giving you the general solution. If they ask you the particular solution, you just have to find this part. So there is nothing wrong that I am doing. Basically I am doing extra than what it is being asked. So here also I am not going to find the particular integral because I saw it in the beginning itself. So what is the pi gentleman? Pi gentleman, here in the right hand side we have sin x. So pi will be 1 by d square plus 1, and that I need to operate on sin x. So if I put in place of d square minus a square, it will become 0. So what we need to do? We need to multiply by x and differentiate this. So d square will become, d square plus 1 will become 2d, and 1 by 2d of sin x. So x by 2, and 1 by d is the integration of sin x, that is minus cos x. So what we got is minus x by 2 of cos x, right? So this is how you can solve questions, right? If I just quickly ask you one question, suppose I ask a question like what is the value of 1 by d to the power 100 plus d, and suppose I say minus 1 of cos x, then how will you solve it? To solve it, you need to actually, your understanding of the thing is that you are replacing d square by minus a square. So if you look at this d to the power 100, this d to the power 100 can be seen as d square to the power 50 and plus d and minus 1 of cos x. Okay, so I can basically write d square as minus 1. So I will write minus 1 to the power 50 plus d and minus 1. So this is 1 and this is minus 1 will cancel, right? So in the end I will just get 1 by d of sin x. 1 by d is basically the integration, so that is equal to minus cos x. Sorry, it was cos x here. Actually I am thinking too fast. So basically it is 1 by dx of cos x. So what I get is sin x. So I hope till now there is no confusion or there is no doubt in whatever I have discussed. So now let us look at some more results which we are going to use in the coming problem. And one of the result is that 1 by fd of e to the power ax into v is equal to e to the power ax 1 by fd plus a over v. So we operate 1 by fd plus a on v. What is v here? Where v is any function of x, right? Another interesting result is that if we have 1 by fd and we are operating it on x into v, then it is equal to x 1 by fd of v, and then d by dt means we differentiate 1 by fd and then we operate it on v. So this v is missing here, I am writing. So d by dd of 1 by fd of v. 1 by d of q I already explained is the integration of q, and 1 by d minus alpha of q is e to the power alpha x, and integration of q e to the power minus alpha x dx. Okay, so let me take few problems based on this. I'm going to take this problem first, and here I'm going to find the pi. I'm not going to find the general solution. It is written solve, means they are expecting us to find the general solution. So I hope you can find the general solution like CF plus pi, but CF part I am putting for you to solve this. So this is a question mark. What is pi, gentlemen? So pi is 1 by d cube plus 3d square minus 4d minus 12, and that I need to operate on 12x e to the power minus 2x. So just for your understanding, if you see, it is something like e to the power ax and a function of x, right? Which result I have to use? First let me write the result here so that you can see the results together and can understand it better. So I told you that we have a result that if I operate 1 by fd on e to the power ax into v, this becomes e to the power ax and 1 by fd plus a, and that we need to operate on v. Okay, so how to solve this problem? Let me first write few steps and then I will discuss. So 12 is a constant, no problem. Here e to the power ax is e to the power minus 2x, and what is v? V is the function of x, so it is x. It may be anything, x square or any function of x, but here it is x, which is also a function of x, right? So what is the process? The process is that e to the power minus 2x will come out of the operator, means this e to the power ax terms comes out. So e to the power minus 2x terms comes out, and then d becomes, d is changed to d plus a. So in place of d I have to write d minus 2. So what this expression will become? This expression will become a long expression. I will write d minus 2 cube plus 3 into d minus 2 whole square, right, minus 4 into d minus 2 minus 12, and that we need to operate on x. Okay, now we just need to simplify the denominator part before we do anything further. So if I simplify it, let me simplify it quickly. It is a minus b whole cube. So how do you get a minus b whole cube? To get a minus b whole cube, you write a cube, that is d cube, minus 3a square b. So 3 into d square into 2, so that will be minus 6d square. Plus 3ab square, so 3 into d into 2 square, so that will be 12d, right? And then minus b cube, so minus 8. I hope you remember the formula of a minus b whole cube. What is the formula of a minus b whole cube? That is a cube minus 3a square b plus 3ab square minus b cube, right? Now if you look at the next term, a minus b whole square, so it will give me d square into 3, so I will get 3d square, minus 2ab, so minus 4d into 3, so that is minus 12d, and plus b square, so 4 into 3 is 12, and actually 12, and then minus 4d plus 8 and minus 12, that we need to operate on x. Okay, so what are the terms that we are going to cancel? This is minus 8 here and this is plus 8 here, so cancelled. Here we have plus 12, here we have minus 12, so that is also cancelled. Here we have 12 d, right, and here we have minus 12d, right? So we can cancel these terms also. So we have now a very small expression, 12e to the power minus 2x 1 by d cube minus 6d square, and what is extra left here? Not 6d square, rather it is, let me make a correction. We have here minus 6d square and we have plus 3d square, so basically we will get minus 3d square, right? Now minus 4d term, minus 4d over x. Okay, now how to solve this? This is also an interesting problem, right? This is also an interesting problem, but before I solve this problem, I just want to explain few things to you, right? I will come back to this problem, but just give me a moment, because if I directly explain to you, you will get confused. So I have to create a background for it. So first let us talk about the background. So the background that I want to give you is related to something that you already have studied. I am not going into very detail, otherwise it will become unnecessarily long video. So I am going to be very to the point. So I am going to use two results. One is 1 minus x to the power minus 1, and this is nothing but the expansion, that is 1 plus x square plus x cube and so on up to infinity. And another result that I am going to use is 1 plus x to the power minus 1. So this is 1 minus x plus x square minus x cube and so on up to infinity. In this case, we are assuming in both these cases that mod of x is less than 1. How do we get this? For that also we can discuss, but then that will go beyond our scope. So because I need these two results, I am going to use this. So suppose we have not discussed anything related to finding something like, suppose I first take a small problem. Suppose I ask you, can you evaluate 1 plus d of x square, right? So when we have to operate on x square, I have talked about exponential function, sine function and other kind of function. But if I have to talk about this function, what we do, we have the expression in the very nice looking form, that is 1 by 1 plus d. So we can write it to 1 plus d to the power minus 1 and x square, right? So now I will use this result, and what is 1 plus d to the power minus 1? It can be expanded. So 1 minus d, then plus d square, then minus d cube and plus so on up to infinitely many terms, x square. Now if you operate this whole thing on x square, there is a term 1 here, so 1 into x square will become x square minus d of x square. So means d is what? D is just the derivative, that is d by dx. So d by dx of x square will give me 2x, and we have to operate d square of x square. So d square of x square means first if you differentiate you will get 2x, and again if you differentiate you will get 2, so you will get plus 2. And if you operate d cube on x square, then you will get 0. So we are actually requiring only the first three terms. All other terms after this, after d square term, when operated on x square will give me 0. So this thing, that what is 1 by d of x square is equal to x square minus 2x plus 2, right? Let me take one more situation. Suppose I take a situation that we have 1 by 4d square plus 3d, and suppose I want to operate it on x square plus 3x, right? These are important multiple choice questions as well. So I am I have stopped the previous problem and came to this so that you get the context, right? So what basically I need to do, our aim here is to somehow get the expression in the form of 1 plus minus something, some function of d. So one way to do is that we can take 3d common, and here I write 1 plus 4 by 3d, right? And that we are going to operate on x square plus 3x. Some of you might be thinking that there is also a possibility that I could have taken 1 by 4d square common, and I can write it 1 plus 3 by 4. We want 3 by 4d. So you see what I will get, 4d square into 1, so 4d square, and 4d and 4d cancel, d square cancels, I will get 3d. But we will not write it like this. This is the wrong approach, because whenever we are taking something common, whatever we are getting in the bracket, in that the d term should come in the numerator, not in the denominator. Why? Because if we have 1 by d behaves like integration, and if you operate integration on this function, it will never be able to, it will never converge, or basically it will keep on increasing. The powers of x will keep on increasing. Think about it. This is slightly important to understand. So pause this video and think about it, and after the video also you can think, right? So what we do, we take 3d common so that we get something like this, and then we proceed further. So we have 1 by 3d, and we write it as 1 plus 4 by 3d inverse, and we operate on x square plus 3x. Okay, now this is a polynomial of degree 2. So if I operate differential operator on this on any degree higher than 2, then I will get 0, right? So I have to, in the expansion, I have to write only those terms which are up to d square. So 1 plus x to the power minus 1. Here in place of x we have 4 by 3d. So 1 and minus x, that is 4 by 3d, and then plus a square of it, so 16 by 9 d square, and that we have to operate on x square plus 3x. Okay, there are many other terms that could be written in this expansion, but there is no need to write those terms, because those terms will be d cube terms. So d cube, if you operate on x square, it will give you 0, right? So now I am not going to continue because I am going back to the original problem. So what we can do after this, or let me continue here, let me use a different ink so that it is not all mixed up. So what after this, what we can do, I am writing here in the top. So I will get 1 by 3d, right? And we have 1 into x square plus 3x, so I will write x square plus 3x, and minus 4 by 3, and derivative of x square plus 3x. So what you will get? You will get 2x plus 3, and then plus 16 by 9, and derivative of 2x plus 3 is equal to 2. Now you will simplify this expression, and you will operate 1 by d, means you will integrate it, and then finally you will get the result. So going back to this problem, let me continue with this problem now. So how to solve this problem further? So to solve this problem further, I have to write 16 e to the power minus 2x, and from this, be very careful, I am going to take minus 4d common. Okay, so if I take minus 4d common, what I will get? I will get 1 plus 3 by 4d from this term, and here I will get minus d square by 4, and that we have to operate on x. You verify, minus 4d minus 4 cancel, so minus 3d square, and this minus minus plus 4 cancel, so d cube. So we are getting this. Now for our convenience, we can cancel this 16 and minus 4. So what I will get is, I will get minus 4 e to the power minus 2x, 1 by d, and 1 plus 3 by 4 d minus d square by 4 whole to the power minus 1 of x. Okay, I hope there is no confusion up to this. So because we don't have a space here, I am going to remove this part, and I will continue here in the top, right, after this. So we are going to use the expansion, and we have a polynomial of degree 1, means we have x to the power 1. So if I write it over from here, so I am writing after this, I am writing here. So I have minus 4 e to the power minus 2x and 1 by d, and if I have to expand this, 1 plus x to the power minus 1, so 1 minus 3 by 4d. It's not sufficient space. I actually have to move better to the next page. So just let me move to the next page. Here actually in this I have made a small mistake. Let me correct it. It was 12 here. I don't know why I wrote 16. So first let me correct this part. So it is 12. So 12 and minus 4, when you will cancel, you will get not minus 4 here, you will get minus 3 here, right? So in the next page what I have written, minus 3 e to the power minus 2x. So minus 3 e to the power minus 2x, and then 1 by d. So I copied it, 1 by d, and this whole thing 1 plus 3 by 4d minus d square by 4 to the power minus 1 over x, right? So what I am going to do now is that I am going to write it minus 3 e to the power minus 2x 1 by d, and it is something like the whole thing should be treated like x. So I write 1 minus x. So 1 minus 3 by 4d minus d square by 4, and plus when there is a positive sign, the sign changes alternatively. I hope you remember the result that I discussed, right? I discussed this result. So so it's a square here, so I will write 3 by 4d minus d square by 4 square, and so on, right? This x. But this I have just written for your understanding. Here we have just x term, the degree 1 term. So if I differentiate it once, it will become constant, and in second order derivative it will become 0. So in this also we just require this term, this d square will make it 0, and if you write the square of it, you have d square, then you will get d to the power 4 term, because a square of this will give you d square, a square of this will give you d to the power 4, and AB term, 2AB term will give you d cube. So basically no term is needed from this part, and similarly the other terms will have d cube and so on. So we just can't there is no need to write the other term. So I'm just writing next minus 3 e to the power minus 2x 1 by d, and then 1 and minus 3 by 4d, right? I'm not writing the other terms like plus and so on, x. So what I will get? I will get minus 3 e to the power minus 2x 1 by d. 1 into x is x, and minus d of x is 1, so I will get 3 by 4, right? So now I got minus 3 e to the power minus 2x 1 by d of x means integration of x, that is x square by 2, and minus 3 by 4x. So this is my PI. It was a long problem, but I would suggest you that please watch this again in case if you didn't get it, right? Because this is an interesting application of this result, right? Now I want to solve this problem, and because it is already quite a long video, but I wanted to solve this one also. So here I just want to find the PI. Even though it is written solve here, I'm just going to find PI. So what is this operator form? The operator form is d square plus 16 y is equal to 64 x square. So I will write 1 by d square plus 16 of 64 x square. So I can take 64 out of it, and then again since it is x square, I have to write it in the form of 1 plus minus something. So I write 16 common, and 1 by d square by 16, right? And that we have to operate on x square. So 64 by 16, it will become 4, and I will get 1 plus d square by 16 to the power minus 1 of x square. So I write 4 and then 1 minus d square by 16, and then plus d to the power 4 by 16 square. And there is no need to actually write those terms because we have x square, so we need to have the term up to d square, because after d square it will all become 0. So I am writing 4 1 into x square is x square minus 1 by 16, and d square of x square. So if you differentiate x square, you will get 2x. If you double differentiate it, means you have to differentiate 2x, so you will get 2. So what did you get? If you multiply it, you will get 4x square, and 2 by 16 means 1 by 8 minus 4, so that is equal to 1 by 2, right? So this is your PI. So we also have applied this result. We already have applied this result. We can apply this result also, but I would like you to solve some problems where this result can be used, and you can consider like some of the problem where the right hand side may be something like x sine x. So please do solve the problem. There are some more problems that are mentioned here. You can take a screenshot of this and try to solve them, and give the answer in the comment section. And in case if you feel like that even though I have tried to solve as many problems as possible, but if you wish that think that I need to create another video where I can take more problems, then let me know through the comment section. This was a very big video, but very important one also, because in the exams lot of questions are asked from this. So in case if you have arrived till the end, please do share with all your friends, like the video, subscribe the channel, and this channel actually will help you to take care of all your mathematics requirement, all your engineering math requirement. And I'm going to constantly upload videos which are going to help you in placements, in other activities also, competitive exam, GATE related. So this is going to be a very important and helpful channel for you. So do subscribe and share with all your friends. That's all from my side in this video. Thanks for watching and have a very great day.